Welcome back, everyone. My name is Justin Frazier, and I am a master's student in BAE under Professor Dr. Naiqian Zhang. The ASABE Student Robotics Design Competition is an international competition that is sponsored by the American Society of Agricultural and Biological Engineers. It has been held annually at the ASABE International Meeting since 2007. The challenge is different every year, focusing on a problem in agriculture that is relative to the location of the competition. This competition was held in Dallas, simulating cattle feedlot production. K-State has participated every year. In 8 years, over 50 students have been a part of the team. If you pass through the hallway of the Biological and Agricultural Engineering Department in Seton Hall, you will find a display with many plaques. The plaques may be small, but they all say first place. Before coming to K-State, I received my undergraduate degree from Oklahoma State University, where I was a member of the robotics team there. I remember having high hopes of winning the competition, but then I saw K-State's design, which blew everyone out of the water. When I came to K-State, I wanted to find out from the inside how Dr. Zhang's K-State teams won all the competitions. What is the secret? To answer this question, I would like to introduce to the stage the faculty advisor for the robotics design team, Dr. Naiqian Zhang.
And I think you should realize that the person at the center of the photo is Justin. He shaved for this event. And I also want to show you Justin wearing purple. He's now the captain of the K-State robotics team for this year. Yes, we've been winning all the competitions so far, but people used to say success does not happen overnight. Then what's the secret? I think the secret is that we have secret weapons. The first secret weapon is motivation. The students and I all realize that the competition provides a golden opportunity for students to learn design. And besides, it's a lot of fun, especially when you're winning. I guess Coach Schneider will agree with this. And the second secret weapon is foundation building. In our BA department, we established a nice series of design courses. Many other courses also provide or ask students to do a class project. In the 3 class projects I'm teaching, students have accomplished more than 150 projects over the past 15 years. And this is an article in a magazine called Resource, which is published by ASABE. According to this article, a student said that rumor had it that Dr. Zhang was determined to make programmers out of everyone enrolled, whether they like it or not. This is probably not true, not completely true. But yes, yes, I want them to learn how to do program, and I want them to make some codes to control some real machines and to feel the sense of success. And our third secret weapon is to aim high. Our team slogan is, we don't enter to compete, we enter to win. And to do that, we apply near perfectionism in preparation. And I know there are slogans from other teams. One slogan for a team is beat K-State. I'm not going to mention the name of that university, but I can tell you that it's not a Big 12 school anymore. Our next secret weapon is to have open-minded philosophy. Every year, we spend tons of time brainstorming. We try to unleash every single possible solutions from everybody's mind. To create opportunities for the students, we select the two best solutions and name them Plan A and Plan B. We send both Plan A and Plan B to the competition. Most times, the Plan A wins, but sometimes Plan B wins too. So, in the competition, we already established a brand name called K-State Design. Everybody knows about K-State Design, and it features very unique design every time. Now, in 2008, the teams were charged to harvest trees in a forest. Every other team sent single robot to harvest single trees. The K-State's design was a gantry that simultaneously harvest multiple trees at one time. You know, this design shocked all the audience, and it also forever changed the rule of the competition. The next year, the committee decided to set size limit for robots. Even now, they said the robot can only be 1 cubic foot big. In 2010, the teams are charged to measure tree heights. Every team sent in a single robot to travel within the forest. The K-State design is still different. We used two inexpensive webcams and image processing to actually achieve 100% accuracy within 9 seconds. The other teams, the best team, used 40 seconds and achieved 80% of accuracy. Last year, the teams were charged to connect maple trees with they called sap pipelines, which is replaced with strings in this case. And black lines are made available on the whiteboard that make everybody think that, including us initially, that we should use the line tracking technique. But then a student team member said that, no, that's not the best way. He thought we should simulate monkeys in the forest when they move from tree to tree using single arm swing. And that's what we did. And this is, again, yet another K-State design, a unique design. And the next secret weapon is to pay attention to details. We prepared for everything. For this one, we anticipated that there may be ladies wearing red clothes nearby the board, and the trees are red. So that will cause confusion for the computer image processing program. What we did, we hang red clothes on the edge of the board and make our code algorithms to overcome this problem. This effort was paid off because during the competition, there are ladies wearing red clothes, but our team was not affected by it. And the next secret weapon is to use high tech. Our students, through the competition, have learned how to do CAD, computer-aided design, 3D printing, and those skills are highlighted in their resumes for job hunting. And through all the competitions, we believe the student gained a lot of knowledge and experience. And as summarized by team captain, Mr. Jed, he said that this is a complete package. Now, every engineering professor in this country knows about A through K, which are the expected student learning outcomes defined by ABET. So I believe through this competition, the competition made contributions to many of these student learning outcomes. So I don't know whether we can teach creativity, but I believe we can encourage creative thinking. We can create the rooms for students to unleash their creative design. And more importantly, we can awaken joy in creative expression and knowledge, as once said by Albert Einstein. Now, to finish this presentation, I'm going to show you one more design, unique K-State design, which actually required automatic dispensing or distribution of a feed. And the K-State did this with an error of less than 50 milligrams for each cell. So with that, I would say thank you, and thank you for having me here.